So at that level, we go into a second phase, and we actually raise the voltage to 118 volts, and that gets us up around 3.7 volts per cell. And we do the same thing again. But we've already put about 90% of the power we're going to get into the back end of this, so this phase doesn't last very long. Again, it brings up the batteries at a constant current level. We use a lower level to be a little gentler on the batteries, 10 amps. And when they reach the 118 volts, it again switches to a constant current, constant voltage source, and the current declines from the 10 amps again down to about an amp. We then have a charge cycle where the charger's simply off for 10 minutes. The batteries will actually begin to decrease in voltage then, down to about 3.5 volts or so. And we'll bring the charger back up at 118 volts and do another cycle of this. And then we'll give it another 10-minute rest before doing a final cycle again at 118 volts. This method of charging the batteries gets them to be fairly even in their voltages across. In fact, we've been amazed at how well balanced, typically to the 100th of the volt, that these cells are across the entire array. And most of the problems that you get into with them becoming unbalanced happens in this zone from 3.7 to 4.25 volts, which is on the very steep side of the charge curve. You're not adding much energy anyway. And so the programmability of the charger is a big factor in being able to charge the batteries properly. And more importantly, letting us to do it without supervising them. Again, you can get battery chargers that will again work on constant current and then constant voltage, and will put out just as much power, just as much current, charge the batteries the same amount of time, but you kind of have to supervise the process too often. The Brusa, programmable Brusa, lets us write a program on the laptop very easily using some very simple software, and then store that in the charger, and that's what it uses to charge the batteries from then on. Because the batteries can be charged at any time, at any charge level, and we're not going to overcharge them using the Brusa at any time, we can charge as often as we like. And in fact, you extend the life of the batteries by charging them as much as you can. In daily living, what this means is I go to the store in the car, I come back, and I charge it. I plug it in. It's like plugging in a toaster. Go in the house, I can come out 20 minutes later and want to go somewhere. It's not a problem. Unplug the cord, lower the hood, and take off again. At night, how long does it take to charge? Why would I care? You plug it in at night, and if it's ready in the morning, we're fine. Since I know we're not going to go over 4.5 or 5 hours, I come in at midnight and plug it in and get up the next morning, and it's going to be fine. So range isn't that important to me, and certainly here in a town in the Midwest, I probably don't drive 20 miles a day, and I do it in 6 or 8 or 10 trips. And so I bring it in, plug it in, and there we go. A lot of the people converting EVs give a great deal more attention to this connector and interlocks to prevent you from driving away with a cord. Again, by putting it under the hood as it was originally in a Porsche, I have to close the hood to leave, and I have to pull the cord to close the hood, so I don't really need to interlock the system. Let's talk a little bit about safety. Again, the Thunder Sky designers have done a remarkable job of improving the lithium ionic battery to the point where we really don't have the problems that we ran into even with the lithium cobalt or lithium manganese batteries. You can overcharge these, you can over discharge them without really any fear of fire or flame or explosion. In fact, they have videos of them firing bullets into the cells, driving nails into them. It does short out the battery, and there's some arcing and smoke, but they don't burst into flames or explode or any of that. Anytime you're dealing with a device capable of that much power, there's some issues simply dealing with them when making adjustments in the car and so forth. You want to remove your watches and rings and so forth. Be careful with the tools. If you get across a couple of terminals, you can weld a wrench across a couple of these batteries pretty easily. This, again, is a 90 amp hour battery. It's capable of putting out 900 amps at any one time for a brief period. Having two sets of them in the car for 180 amps total, I can actually apply 1800 amps to the controller. Now, it's the controller we have is limited to 1200 amps to the motor, but that's an immense amount of power, roughly equivalent through the controller of about 200 horsepower for brief periods. I've heard a lot about toxicity and the environment and the availability of lithium. First, a lot of this is largely mythological. There isn't really any lithium metal in the battery, for one thing. In fact, the battery is quite benign with regards to environmental considerations, even on disposal. Nickel-cadmium batteries, nickel metal hydride batteries, and lead acid batteries all have significant toxicity levels in the materials that are in the batteries that make them kind of a disposal problem. This battery is aluminum and copper. The lithium is a phosphate that is not toxic at all, and there's so little of it that it's not really probably worth the conversion process to get what little lithium metal you could get out of that. The availability of lithium. They go on and on about Bolivia having the only lithium. Well, that's a little bit of a problem for me. We would have run out of oil 6 times if the projections of how much we had were used up. As something goes up in value, you have more people looking for it in order to make money. No one's really been out looking for lithium. In the case of the Thunder Sky, they don't use lithium at all. They use a saline lithium carbonate that they get out of a mine in China. So what Bolivia's position is on lithium, I don't think really matters. The projections of 30,000 tons of lithium in the world are simply nonsense. We don't know how much lithium's in the world. It's a fairly rare element, but it exists in almost all continents, and undoubtedly here in the United States, if it was valuable enough for anybody to go look for it. So as we convert cars to lithium battery technologies, I'm confident there'll be more found. I think we're going to wind up moving more and more away from lithium as a metal and toward these phosphates and oxides that are much safer, much more durable, don't have quite the power capability that a pure lithium metallic battery would have, but we're past those anyway. They were simply too dangerous. So there'll be plenty of lithium to make batteries from. I do think the cost of all this will come down fairly dramatically, and there are some fascinating sciences and engineering out there already that would vastly improve this car, where we could drive 400 or 500 miles without a whole lot of effort. The basic problem is if you did develop a heavy battery like this for automotive use, who would care and who would you sell it to? And so we wind up with most of our existing patents and developments in lithium battery chemistries simply aren't funded for development because they're not sure there's a market for them. That's changing slowly. We have the chicken and the egg. The cars need the batteries, and the batteries need the cars. But as more people become familiar with them, I'm confident that even that'll be broken. The company called Altar Nano has actually gone away from cathode research and have been working on the anode side, and have come up with a lithium titanate spinel that in place of the graphite that makes it where you could charge the battery in 10 minutes. Again, the battery is not really the limitation, your power source is, but it's a significant enhancement in battery technology. And I think if there were a demand in an industry producing these batteries, particularly here in the United States, that we'd see some truly amazing advances in battery technology for the cars. This has been locked up for 20 or 30 years with really not a whole lot of advance because of the lack of the market.